I see so many faces here. And again, thank you, Lunar Lincoln. You guys have been an awesome host for us the past couple years. It's been truly awesome to have you guys, so thank you. All right, so today we're going to be talking about code generation. And what is code generation? Well, it's basically a set of tools that can help write code for you. And no, it's not going to put us out of jobs. It can only solve certain problems. It can't really just, write your whole app for you, but it can come in really handy if you have some kind of repetitive task. You can kind of automate that to generate that code for you. And it can save you a lot of hassle. It can cut down on the amount of bugs that you write. Any way you can reduce the amount of code you write is going to mean less bugs for you in the end. So I think that's always a good thing. It usually comes as some kind of build script or tool that you integrate into your build process, and it'll run and generate some code, and then that'll get compiled with the rest of your code. So that's kind of how it fits into the process there. It can reduce boilerplate. If you find yourself writing the same kind of code over and over again, it may be an opportunity for code generation. It can extend your language, Swift or Objective-C or whatever you're using. It can extend the language to provide new syntax or new patterns that would otherwise be kind of a hassle or impossible, to do by hand all over the place. And it can also give you some additional type safety. You'll find there's some code generation tools that kind of come with their own framework, and it'll generate code with that framework and kind of add type safety where it didn't exist before. So we're going to see examples of all of those things here tonight. We're going to start with something that you may already know about. I think we talked about this in a previous meetup, which is synthesized protocol conformance. This is a new thing in Swift 4, I want to say, but you see we have our struct here. Say this is a airplane flight. It's got an airline, a flight number, and a departure date, and we'd like to be able to compare these flights together and see if they're equal. We'd like to be able to do encoding and decoding, like from JSON, and then generate hash values for those flights. And with the latest version of the Swift compiler, you can just attach those protocols and it'll actually generate the implementations for you, which is really cool. And how can it do that? Well, the Swift compiler already knows about what properties you have defined here, and so it's not a hard task for them to say, oh, okay, well, if you want to compare flights, we'll just compare each of those properties. And they have equatable implemented for strings and ints and dates, so they spit out some code that compares those properties, and now you can compare these structs, which is really handy. I think for many years we've all been writing that code ourselves, and it can be painful. If we add a new property, we have to remember to go and update all of our conformances to think about that new property. Should we compare it? Should it be encoded and decoded? And how does it play into the hash value? So that's a really nice example that comes with the Swift compiler. But you might be thinking, well, what about my protocols? What if I have my own protocol and I want to generate some code from my classes or structs or whatever to implement those protocols? So there's actually a tool that we're going to look at today called Sorcery. And Sorcery can help you generate code based on the types and the properties that are in your project already. It uses SourceKit, which is kind of the framework for parsing Swift code, and you can get information on what types are in the project and what their properties are and what they conform to, and basically all the things that a compiler would know about. You can kind of access them through the SourceKit API and generate, maybe generate code, maybe do like diagnostic type things. So it uses SourceKit to learn about your types and everything, and then it's going to use templates to generate new source files. That is your generated code, and that gets compiled with the rest of your project. So go ahead and open open up our project here. Oop, not that one. I think I have 3 different Xcode versions on here.
Multiple clients.
Yep.
How big is your hard drive?
Not big enough. Right, here we
Good applications.
go. Okay. Sweet. Alright, so let's get back to, so let's say we have a protocol here. We want to turn our models into dictionaries and be able to parse them back out from dictionaries, which is still something, you know, the new codable stuff with Swift, it's great if you're turning your stuff all the way into JSON data or like XML, but you always end up with like data or NS data on the other side, which you may actually need that intermediate like dictionary representation. There's some APIs, like maybe your networking library takes in dictionaries, and so going all the way to JSON is not what you want to do. Like I'm currently using Firebase on a project, and you can't, like, I don't want to parse it into JSON and then give it to the, like, I just want to give them the dictionary. So this isn't a solved problem in the Swift language. Like there's no coder, you know, encoding that will do that for you. So how do we start? Let's say we've got which one is it here? All right, so so let's say we have a ticket, like a, you know, plain ticket or something here, and we'd like to generate that dictionary representation for this model and be able to parse it in and out of dictionaries. So with Sorcery, you get to annotate your types with this little comment. If you lead the comment with this Sorcery tag, and then you can put stuff after it that'll give Sorcery some information that you can work with in your templates. So in this case, we're kind of just tagging this type as, hey, we want to generate that dictionary representation, and that's great. And then so how do we use that with Sorcery? Well, secondly, we have a template here, which is a little messy looking, but they use the stencil templating library, which is kind of like Handlebars or a lot of web templating frameworks. Like we'll use the same kind of templating stuff to generate web pages, but in this case we're going to generate a source file. So briefly, just looking over this, this is kind of the format that we're going to output here. And it's going to interpolate some values and generate the actual source file for us. So, you know, we get all the types that are annotated, dictionary representation, and then we're going to start spitting out some code. You can see we're going to do an extension with the name of the type and then the protocol. And here's this toDictionary method. We're going to loop over the variables of that type, and then we're just going to create a dictionary and then stick all those values in the dictionary there. Anywhere you see these double curly braces is where we're going to actually interpret a value from the into the template. So, you know, we'll go over each variable, stick it in a key for that dict, and then give it the value there. We'll loop over those. You see this for loop here, for var and type variables. And then we're going to do the same thing in reverse to parse it back out. We're going to have some guard statements to make sure that we get everything out that we want. And that's really all there is to it. So you see how that's kind of a template for what we're going to generate.
Quick question.
Yeah.
Is the benefit here that I'm seeing is because you have access to that variables property, which you wouldn't get from a protocol extension?
Yes.
Okay.
Well, so, you know, I could write this protocol myself, but the trick is if I add more properties later, I have to remember to go and update my extension.
Right, that's what I was...
Right,
Okay.
so I've actually got Sorcery integrated here as part of my my build phases. Let me take a look at that. Yeah, here's Sorcery. We just tell it, hey, here's my template, here's where I want you to output stuff, and then you just run Sorcery. You know, from CocoaPods there, they have a executable file sitting in there. That's the script. And then so what do we get on the other side? We get this nice generated file. You can see generated using Sorcery, and it, you know, parses out all the properties and puts them in the right place and does the same thing in reverse. And so because it's integrated as part of my build phases there, I can actually go in here and add a new property. Let's say, you know, maybe the ticket is refunded. That's a Boolean. And now we're going to watch this file here, run the build again. Oh, where am I? Oh, there it is. Boom. Auto-magically added this new property here to the parsing logic, and so that's really great. I don't have to think about if I change the properties and stuff, is it going to know to update all this stuff? Happens automatically. It happens before it compiles the code. Yeah, that was the other thing. Is you'll see these build phases are always before compile sources. Like we want to generate the code and then compile it. So. That's kind of how that works. I can go back in here and remove that, and on the next build it will take that stuff away. Yay!
Wow.
It's very magical. I love magic. So great. So you can see how we can use sorcery to do our own kind of synthesized conformance and generate stuff on the fly, based on types and very properties and all that stuff, which is really great. Now, how do I get back to Keynote here? Yes. I gotta hit play again. All right. So sorcery, pretty awesome. We can mimic the Swift compiler and generate kind of stuff on the fly like that. Really handy to be able to do. And so you can see we're using like our Swift source as kind of the source of information that lets us generate new code, but maybe there's other things we can use. Outside of SourceKit, we can leverage information, like maybe there's a file in your project that tells you, hey, I need to, we would like to have types for these kinds of things, and we can generate source from other things, not just SourceKit. So one good example that maybe you've used before is core data classes. How many people have used core data, are using core data? Awesome. Okay, cool. All right, so with core data, you're probably already familiar with, or here, let's stick in here for a second. So you create kind of your schema file, your model file that says, here are all my types, here are their attributes, name, ID, whatever, and then Xcode can read that schema file and generate some classes for you. I feel like that's probably the most common form of code generation that I've encountered in my time doing this. So schema file generates some classes. It will even generate some type-safe fetch requests, which is fairly new. I want to say in the last year or two they added that. And so we're going to just look at that really quick and see how that works. Oh, wrong one again. This is what I do all day. I just open the wrong Xcode.
It's that one.
Why is one of them in dark mode and the other one's in light mode? What happens?
I don't know that 9.4 got...
Oh, it doesn't support it yet. Okay.
Yeah, it was never updated for that. Okay, so here, close this. In case you haven't used core data before, this is kind of what our schema looks like. These are our types. I've got trains and passengers and reservations, and I guess I'm building a travel app. I don't know. That's just kind of what I ran with here. And then they've got attributes like name, age, relationships between them, and whatnot. So if you're using the Xcode generation for this, you would click on Create NS Manage Object subclass. You pick the model you want. You pick the entities you want, and it'll spit those out. I've already done that over here. So Xcode will spit out like, hey, here's your passenger class, and it has those properties, and now we can query them from core data, and it'll use that database, the backing database, to kind of be the backing store for these classes. And we get a nice fetch request here that's generic over the type you're querying, and so we can see that here. Let's say we're gonna let's say we want to fetch the adult passengers. Maybe, you can't sit in the exit row unless you're an adult, right? So we have to write this logic here. We're gonna get a fetch request for the passengers class. We're gonna add a predicate to it. Let me get this so it's not line breaking. That's easier to read. So you see we're going to, compare that age property to the number 18 and make sure we only get passengers over age 18, and then we're going to execute that fetch request here. That's pretty cool. It knows the fetch request is going to return passengers because of this kind of generated code right here. But if you look at this, this is not great, right? We're using strings here, and we have no real guarantee that this property really exists, and we should be comparing it to a number, but what if I forget? I type A, B, C. Xcode doesn't care if I do that. It's very happy with that. And what if I mistype this here? AB, that's not a property on the class, but Xcode seems very happy to do that, which is not great. And we should be able to fix this, right? Because our schema file has all this information in it. So we should be able to generate some code to make this a little bit safer. And so we're going to actually look at another library now, which is called play button. So can we do better? Can we leverage that? Can we leverage that schema file to generate some stuff to make those queries a little bit safer? So there's a framework out there called Core Data Query Interface, or CDQI for short. Basically, it does exactly what we were just saying. It's a Ruby gem that will read your schema file and spit out some types, and then we'll use those types to actually generate the predicates instead of working with the strings directly. So we've got a command line tool generate Swift code, and we'll get type safety on both, what attributes are there, make sure we don't query against an attribute that doesn't exist, and also make sure if the attribute's an integer, we should only be able to compare that to other numbers and not strings. So let's take a look at how that works. Back open. So similar to sorcery, I've got a build step in my build phases that will run the CDQI tool. And what that outputs is these kind of types right here, which basically say hey, this is going to be the representation of that passenger type. It's got an age, which is an integer 32 attribute. And it's got a string, that's the name, it's got reservations that links out to, another type. And then they give us a little handy API to use these types to actually build the query. So what you see here is we're saying, from the passenger class, we're gonna create a query, and then we're gonna filter that query. And this is allegedly the passenger. We want their age to be at least 18, and then we're going to get all passengers that meet that criteria there. So this looks like we're comparing, the passenger, we've already queried it out and we've got it, we're comparing it in memory, but that's not actually what's going on here. This passenger is actually that passenger attribute. So it's kind of just a representation of the class there. How do we go back here? Forget. Boom. So this comparison just says hey, we want to compare this property to this value, and they've overloaded this operator here to, instead of comparing those things and giving us a Boolean, this actually gets translated to an NS predicate. So it's a neat kind of domain-specific language for generating NS predicates, and it uses a lot of NS expression. This is the property expression, this is a constant expression, and then this is a comparison predicate that generates an NS predicate. So that's really nice because now if we go and let's say I changed age, let's say I misspell it, boom.
Out of my box.
When I try to build again, it's going to say, no, you can't, there is no property called age. You rename that to something else. And so, let's fix that again. Oops. Cool. So this should be good again. And then also, you know, if we accidentally try to compare it to a string, it's not going to like that either. Yeah, it just doesn't know how to compare those two things. So that's really, really handy because I don't know about you, I've worked on projects that had probably 100 or more, you know, core data queries. And if you need to rename one property, it's like, okay, well, I got to find and replace like that thing all over. And like, who knows what I'm comparing them to and how do I find and replace like all of that. So this is like really, really helpful to me. It just helps you make sure that your queries are defined correctly and not going to crash. You see like this try statement here, if you get those things wrong with a normal core data fetch request, like it'll just crash. Like when you try to run that query, it'll just crash. And I found that people don't like it when their app crashes. They tend to not prefer that. So I find that is a super helpful library. And yeah, so if you're using core data, you should think about using CDQI. And if you're interested in how that all works, I did help contribute to this library and helped add this functionality here. It really taught me a lot about Swift generics and stuff like that. So it's actually a really interesting project. Cool. And so you may be thinking to yourself, that's all well and good, but you write Objective-C, you don't get to use any of this fun stuff because those were all tools for Swift. But it's great because Objective-C has its own kind of code generation tool, which is the Clang preprocessor. The Clang is basically the front end of the Objective-C compiler. It also compiles C and C++. And the preprocessor basically says, hey, we're going to let you modify your source files like before they go into the compiler. So you can do code generation, you can do conditional compilation, which is like, hey, I only want to compile this code like for debug builds, and otherwise don't compile it. So that's kind of, it's not really code generation, but it is another kind of pre-processing. You have to be a little bit careful because these macros are not what they call hygienic macros. You may see languages like Rust and Clojure advertise hygienic macros, and we're going to see what that means really. You don't have a ton of control, you're just manipulating the string that is your source file. So you can kind of make some mistakes that will end up biting you. It's not a super clean process. So we'll jump back over to Xcode. Get my mouse. Cool. So we'll go to my Objective-C file here. So this probably looks familiar. We've got, you know, a string, a method that generates a string, and then we're assigning that to a variable. That's all well and good, but if you're like me and you're used to writing Swift, like this is kind of a pain. Like the compiler should already know that this is going to be a string, but we have to kind of declare it again right here. So they actually introduced some stuff in Objective-C to make this a little bit easier, which is auto type, and that basically just says, hey, you're gonna infer what the type of this variable is from whatever's on the right side of that expression. So you get kind of the same type inference that you have in Swift, and then say, you know, you want it to be, you don't want anyone changing this string pointer here. You want to make sure it stays assigned to this initial value. So you can use const. That's normal from C. And that's all great. Still compiles. See, it's giving me a little warning just because I haven't used this variable, but that's all right. But it would be, like, that's nice, and that's all well and good, but it would be a pain to type this everywhere you wanted to do it, right? That's like some 12 characters right there just so you can get type inference and immutable variable there. So we can actually make a macro that will basically do that for us. So you see these macros are always start with a hashtag, pound sign, hashtag, whatever you want to call it, hash symbol define, and then this is the name of the macro, and then this is what it actually expands to here. So you'll hear it saying like this is the macro, and then this is the macro expansion. This is what it gets replaced by when it goes through the preprocessor there. So we can actually just take this out and say let. And now it looks like Swift.
Wow.
Wow.
Now we need something for semicolons, right?
Yeah. So that's really cool. That's awesome. I feel like I'm writing Swift again. I get type inference. I get immutable variables. Like if I try to change this down here, you know, it's not gonna like that.
Semicolon.
Oh, well, good call. Yes, we need a semicolon. Okay, I can't reassign that variable because look, it's const. It's constant. You can't reassign it. Yeah. So, but yeah, let's say you do need, you know, mutable variables there. We'll just have another version that doesn't have that const directive there, and we can change this to var. And look at us. We're doing so good. We're writing some very, very terse Objective-C code with all the niceties of Swift. And
All of them.
okay, maybe not all.
One or two.
Maybe not all of them. Yeah, so that's pretty cool, but here, I want to show you one way that this is not great. So let's say, you know, we've got this unused variable warning here, and maybe that's fine. Maybe we just want to run this string method here to do whatever it does, and we don't really care about the result. In Swift, you know, they use kind of the underscore as a placeholder for an unused variable, and so Objective-C has this unused directive here, and we can use that in conjunction with the macro to say like, hey, we're not going to use this, and now look, that warning has gone away. Now you might be like, well, I don't need this variable name here, so, you know, I'd like to, you know, maybe hide that. Maybe we'll just put that as part of the macro, like make the variable name there. So now that looks like Swift, you know, nice and short. You know that something comes out here, but you're not going to use it. You don't have to name it. But the problem is like, what if I do this again in the same method? It says we've redefined var1 with a different, you know, because we've used this same variable name for both of these variables, and you can't do that. So if you're using this macro, you see this, and then you do this, and you're like, var1, I don't even know, where did var1 come from? Like, I don't know what that is. I didn't write var1, so like, so this is what it means when they say they're not hygienic macros. They can leak. They leak information into the enclosing scope, like with new variables or new function names or things like that, things you don't see when you're looking at the macro that actually affect the enclosing scope. So that's how they can be, you know, a little bit annoying to work with, and anyone who uses a crazy amount of macros like has to deal with that somehow. But you still get some nice stuff. I mean, it's not too bad to just have this. So yeah, that's a short dive into Objective-C macros. You can do a lot more stuff with this. Like they can actually take variables. Oops. You know, if you want to pass something into the macro, you can do variables like that, and then like reference, you know, the variable somewhere else in the macro, and it'll all get expanded, which is nice. So you can do a lot of stuff with them. They're just not super easy to use, but they do work. And it can, you know, it can make your life easier there, which is nice. Fix this. Code must compile. All right. Cool. Let's jump back over here. All right. So that's a brief overview of code generation. Obviously, there's a lot you can do with it, and it's kind of up to you to figure out like. You know, how do I want to extend the language or improve my development workflow? you always want to be looking for kind of ambient information in your project, like that model file. Like, hey, here, all this information's right here. I could just use that to generate some code, and then I won't have to worry about, or you can use SourceKit in the case of sorcery and say, hey, like, SourceKit already knows about my types and properties and protocols and stuff, so I can use those in the templates to generate code, and that's kind of what makes it really useful. You saw that we got rid of some boilerplate. We didn't have to, we were able to synthesize a conformance to our own method, and we got rid of some repetitive stuff. So, really handy stuff, and that's about it. Any questions?
Could you show me your pod file?
Yes.
I just want to see
Yes. It's very short. Pod file. Always keep it in the project. So yeah, core data query interface and sorcery. That's all I'm using there. And then the trick is that
First time I've seen 11.4, man. I've still got 10. And
yeah, I know. Yeah. And then the trick is you have to put these compile steps in here,
above,
your build phases. It's a little, sorcery was nice. CDQI was a little bit harder to integrate because it's a Ruby gem.
Mm-hmm.
And
if you use Fastlane, you should be good with that, though, right? I mean, it's...
So the trick is, like, it works fine, and then when I do it in this build phase, like, Xcode is using a different version of Ruby.
Ah, okay.
Like, Xcode's using the system version of Ruby, and it wasn't able to find the gem. I went through a whole mess trying to fix it, and I eventually just ended up dragging the Ruby file into my project. Yeah.
Add the framework, yeah.
Yeah, and I actually have it wired up here. It'll find all of your model files, like if you have multiple, and it'll spit them out in the same directory. So this will be open. It's already open source on GitHub, this project. I'll post a link to it in Slack. So you guys can kind of use that as a starting point. Any other questions? Yeah.
I know if you use the core data like generator thing, and if you want to like add functionality to that, the recommended way to do that is to like write an extension in a separate file, because if you regenerate it with core data after making a change, it'll just overwrite all that.
It does do that. Yeah.
So with in general with these tools, is that like a common thing among these code generators that you should write functionality and extensions in separate files?
Yes, totally. With CDQI, it's kind of nice because their generated code is pretty self-contained. I never really need to extend this stuff. But yeah, you can see like invocations will overwrite this file. So edit at your own risk. So yeah, you don't want to make any changes here. Like, and the same with sorcery. Here's the output. It probably says like
do not
edit. So yeah, you want to separate like code that you're gonna edit versus code that's being generated, because otherwise it'll just kind of squash. It'll overwrite it. Yeah, good question. What's up?
So I'm guessing these are tricky to run on like CI/CD environments.
That's a really good question. Sorcery works great. It's just a CocoaPod, and their executable is in the CocoaPod, like in the pod itself. So it's really self-contained and easy to integrate. CDQI, again, I had trouble getting it like integrated, but now that it's just in the project, it's just a single Ruby file, so I didn't feel crazy bad about like kind of just dragging that in.
Totally, yeah.
But yeah, like if for CI, you may want to have like a gem file and the gem spec and the install bundler install or whatever it is to get that working. That's a really good question. And yeah, like you might have a different version of Ruby on that machine.
Yeah, that just sounds like a big headache.
That is a really good question. Yeah, I'd say sorcery works all right because it's in Swift. It's written in Swift, and so in theory you already have a working Swift compiler there. But yeah, Ruby versions are such a pain to deal with. I hate dealing with that. So really good question. That's definitely a concern. What's up?
And kind of to that note, do you typically advise checking these auto-generated files into your source?
I do. Yeah. I recommend that just so you can make sure you know when they change. Yeah, it's weird with the Xcode, like core data generation. I have the manual version here, so I see the source files. But if you use their automatic generator, like you don't even see the source files. And I'm like, what? Where are they? And what are they? Like I don't know. So I like to check them in just so you can see when they change and like code reviews and PRs and stuff. Like you're aware of what's going on. But I don't think there's any harm in checking them in. As soon as you run the build, they'll be updated. So even if they're like out of sync or something, they'll always be recreated like every time correctly. So you could leave them out if you wanted to. Any other questions? Awesome. Well, thank you guys for listening.
Thank you.